now we had reached this point. Okay, we had started talking about miscible liquids, or uske andar we had talked about two soluble liquids in each other, and it could be more than two as well. Okay, you can have more than two liquids. You can have many different liquids dissolved in each other. So more और more. ठीक है, ये मैं बीच में ऐड कर देता हूँ. So it could be a number of liquids that could be mixed in each other, and as long as they are soluble, separation happens because of differences in boiling points. और आपके पास you have this apparatus which is like a simple distillation. It has a condenser, except that there is a fractionating column, and I told you the purpose of the fractionating column. Okay, if you have two or more liquids, what is going to happen is that your two liquids, ethanol and water, they have different boiling points. So ethanol is going to evaporate first, and the particles of ethanol are going to go all over. They're going to change into gas. They would pass through the fractionating column into the condenser. They would condense and they would turn into liquid. Uh, but at the same time, some water molecules would also evaporate. So to prevent the water molecules from reaching the other point, what is done is that these glass beads or some other way. The purpose of the fractionating column is to increase the collisions. So the water molecules would collide with the particles or whatever that's present in the fractionating column, and they would lose energy and they would fall back into the container, because uh, 78 would not be the boiling point of water, which is why it will condense very easily. Ethanol, the same thing would happen with ethanol as well, but at 78, ethanol is by default in gaseous state. So the chances of ethanol condensing back would be very little at 78, because that's already its boiling point. And the temperature of the thermometer is going to tell you. The thermometer at the top, it's always placed at the opening. TK will be asked about this. TK, it's usually placed at the opening of the condenser. That basically tells you that. One second. So that basically tells you. Please don't chat over here, especially अगर आपस में करना है तो आपस में आप बात कर लो. अच्छा, so the thing is what's going to happen is, just one second. नहीं, प्लीज अपनी चैट आप ऑफ करें. Just a second. So what's going to happen is that the water molecules so the temperature is going to vary like this. That ethanol would the temperature would stop rising at 78, and then it would start increasing again once all the ethanol has evaporated, and then it would become constant at 100 as well. And you're going to, until the water starts boiling, the temperature remains constant when a change of state is happening, and then it's going to start rising after that. So moving forwards, there's a specific example for fractionating column related to fractionating column, and that's fractional distillation of crude oil, which we're not going to do right now, because that requires some knowledge of organic chemistry. So we're going to leave that for now. Okay, when we do organic chemistry, we're going to cover that then. अब ये कि the next thing is, and the next one that we're going to talk about is two immiscible liquids. How do you separate two immiscible liquids? Now, immiscible liquids are liquids that don't mix with each other. Okay, that's what immiscible liquids are. The liquids that don't mix with each other. So you've got plenty of examples for that. Oil and water is one example. So, for example, you've got oil.
Sir,
Yes. Do you have a question? ठीक है, chat में open करो. You can ask questions on chat. As a soil and water is one example, and now oil and water, they don't mix. So what happens with oil and water is, okay, there's going to be water usually at the bottom, and there's going to be a separate layer for oil, which is going to be at the top. There's going to be a separate layer of oil that's going to be on the top. No matter how hard you try it, they're not going to mix together. Okay, they're always forming separate layers. Usually molecules don't mix when they don't attract each other. So oil and water are kind of, they don't really mix, they don't attract each other, so which is why they don't mix. Now to separate them, there are two ways. There's actually one way, but there are two separate apparatuses that you could use. The method is decanting. So again, decanting would be used. That literally means to pour off. What you could do is, for example, if you have the speaker and there is oil at the top, you can just simply tilt the or pour off the oil from the top. The oil would come first, followed by the water. That's decanting. It literally means to pour off. Okay, now that's one example, or one way of separating two immiscible liquids. But there's a separate device that's known as a separating funnel. That is also frequently used. The separating funnel is something like this. It's so the separating funnel has,
Sir,
yes. Anna, do you have a question?
your voice is lagging, so can you please repeat?
अच्छा ठीक है. Is it lagging for everyone?
No,
Yes.
sir. No, sir.
अच्छा चलो ठीक है. I'm going to repeat. ठीक है. I'm going to just talk a little bit slowly so it doesn't lag. ठीक है. It's यहाँ पे I was talking about immiscible liquids, oil and water. Uh, अच्छा ठीक है. अच्छा, so oil and water, they don't mix. ठीक है. That was what we were talking about, and we're learning how to separate oil from water. And the way to do that is because they're two separate layers, so it's kind of easy to actually separate them. You can simply pour off the oil first. ठीक है. If you tilt it, the oil would come first, uh, and the water would come later on. Uh, so that's one way of removing the oil from the water. That is pretty much what you do. Like if you boil milk at home, it has a layer of fat on top of it, and that's how you decant. Uh, but there's special devices in the lab which would help you do that, and that's known as a separating funnel. ठीक है, so that one is known as a separating funnel. What you do is you put the water and the oil in that separating funnel. It's a mixture, so uh, there's water at the bottom and there's oil at the top. And the separating funnel has a tap at the bottom. You can simply turn on the tap, the water would come out first, followed by the oil that would come out later on. And that way you can simply separate it. Okay? So there's special apparatuses available for decanting substances. I mean, one way is you can just simply pour things off. The other way is you decant. Now, moving on, further separation techniques. Okay, so the next one, I said the next one is chromatographies. Let's start talking about chromatography. Uh, Now, this technique is specifically for separation of dyes. So, if you have different colored dyes, you can separate them using chromatography, and it's used in biology a lot. So, separation of amino acids or other biological substances. And the reason these things dyes, let's focus on dyes and amino acids because most of the questions are related to dyes and amino acids. So, for example, green is a mixture of blue and yellow. Uh, so you can separate the green dye into its components, which are blue and yellow. And the way that is done is that different components or different substances in the mixture have different solubilities, which means some of them would be more soluble than others. You can also do this experiment at home, TK, which I would recommend that you send me pictures of that experiment. I'll tell you how to do this experiment at home. Uh, so first thing, TK, starting from the basics, separation is happening because they have different solubilities. What does that mean? What that means is that in chromatography, you take a piece of filter paper or a chromatogram. Uh, if you haven't seen what a filter paper or a chromatogram looks like, it's like a tissue paper. You get something that's very absorbent. I mean, it's a better version. Like if you have a high quality tissue paper, that's what a chromatogram or a filter paper actually looks like. So now, so you have this at your home. Just take a piece of good quality tissue paper. Even a bad quality tissue paper would work. That could act as a chromatogram or a filter paper. And what you are going to do is, and you'll be asked to draw label diagrams of chromatography experiment. There's a line that's usually placed at the bottom, and that line is made from a pencil. It's known as your starting line, or your all your calculations are going to be made from this particular line. That's your starting line, uh, and it's drawn in pencil. So it's a pencil line. And the reason you draw it with a pencil is, and you'll be asked this question in your exams as well. The reason you draw it with your pencil is that it's pencil, a line that's made out of pencil that isn't going to get affected by water or any solvent. So it's not soluble in water, for example. So the line would not, like if it was made from an ink or any pen, any ink, that ink would become, it would kind of uh, it would dissolve in the water and it will spread. So you don't want that to happen. You don't want the starting line to actually change. You want the starting line to remain as it is. The next thing is you put a uh, किसकी हम बात करें? I think green. ठीक है. Let's say I have a green dye which is made out of blue and yellow dyes. So what I'm going to do is I'm going to put a dot, and I hope everyone has a green pen or a green marker. Just put a dot on that starting line. Okay, if you do that, just place it over there. And the next part is dip this chromatogram. Okay, or at home you're using a tissue paper. Dip that chromatogram or tissue paper in a solvent, and the solvent level has to be below the starting line. So you dip it in a solvent, and usually I mean, it could be any solvent. It's not necessarily a fixed solvent, but usually the solvent that we have is water. So let's try water. Remember, you could use any solvent. It doesn't have to be. It's not fixed. It's not always water. It could be any solvent. Uh, and also remember, the solvent level has to be below. It has to be below the starting line. Because if the solvent level is above the starting line, the problem would be that the green dye would mix in the solvent, in the solution, in whatever glass the solution is. It's going to mix in that solution. So you don't want that to happen. So I'm going to write. So otherwise, so you want to keep the green dot above the solvent, okay, not close to it. So otherwise, the green dye would dissolve in the solvent. Yes. एक से आवाज आ रही है. So otherwise the green otherwise the green dye would dissolve in the solvent, and you don't want that to happen. अच्छा अब slowly क्या होता है, you must have seen कि if you dip one end of the tissue paper in a solvent, the water starts traveling up, even the dry part of the tissue paper would eventually get wet. Why? Because it's a very absorbent material, so the water would start to travel upwards immediately. So the water level would start to rise. Okay? I mean, this is exactly what happens. I mean, you can try this at home. You must be aware of this. Just dip one end of the tissue paper in a glass of water, and the water would eventually, the whole tissue paper would start becoming wet. Okay? So the water would start traveling up because of the absorbent nature of the material that you're using. And as the water starts to travel up, remember green dye was made out of blue and yellow dyes mixed together. So what eventually happen is that the blue dye and the yellow dye, they both would start traveling in the upward direction along with the solvent. So both of them would start traveling upwards. Okay, they're going to dissolve in the water, so the water comes close to the I mean it gets absorbed into the filter paper over here, and the water starts rising up, and the water starts taking the components of the green dye along with it. So if the dye is very soluble, it's going to travel a longer distance. It's going to start traveling with the water. If it's not very soluble, it's going to stay behind. So it depends. The two dyes would have different solubilities. One of them is going to be more soluble. The other one would be less soluble. So as the water rises up, the yellow dye would start traveling up along with it. ठीक है, यहाँ पे show कर देता हूँ. So the yellow dye would start to travel up, and the blue dye is not very soluble, so it's going to remain behind. It's not going to dissolve in the water that much. As aim in the solvents could be, I'm going to talk about the solvents in a bit. Okay, you could have any solvents. Okay, you could have any solvents as long as this condition is met, that the mixtures are supposed to have different solubilities. Because if you use a solvent and the component dyes, they don't have different solubilities in the solvent, then the separation would not happen or would not take place. So
Sir,
yes, so they're going to be different types. एक second now. I said, so they're going to be different types of solvents. I said, there are going to be different types of solvents. Solvents के ऊपर ही मैं फिर से mention कर लूँ कि as a solvents, I'm just going to name a few solvents. A lot of solvents. I mean, one of them is water. That's obviously one solvent, but you've got many different types of solvents. For example, you've got ethanol. Okay, that's another one. Usually, they would be given in the question. You don't have to remember the solvents. Okay, any liquid could be used as a solvent as long as the mixtures have different solubilities. If they don't have different solubilities, फिर problem ये होगा कि the dyes would travel exactly the same the same distance. You've got hexane. That's also frequently coming in the questions, but no need to remember these solvents. Just remember the first one, water or ethanol. Okay, that would be sufficient. I said so. Coming back to this, now there's going to be a point. The solvent is going to travel the largest distance. Okay, so the solvent would be traveling the largest distance. So there would be a thing called a solvent front right at the top. Now the solvent front is the point कि जहां तक ना the water has traveled, and after that it's dry. So think of a tissue paper. You've dipped one end into the solvent, and the water is traveling upwards, and this part is wet, and the top part is dry. So the difference between the dry and the wet part, that's your solvent front. That's the point up till which the solvent has traveled. So the solvent front is always at the top. Okay, the solvent covers the largest distance. And the dyes are continuously dissolving in the solvent and they're traveling along with the solvent. If the dye is very soluble, then it's going to travel a longer distance. And if the dye is less soluble, then it's going to travel a smaller distance. So this is a dye that's traveling, or we can say that it's more soluble. And this is the dye that's relatively less soluble. ठीक है ये सारों को clear है? Is this clear? Any questions? Eamon, is this clear? बाकियों
Yes, it's
ठीक है
clear.
ओके सलामा uh, अच्छा coming to the next point. So the rule is separation would only happen if they have different solubilities. Because if they don't have different solubilities, if they have the same solubilities, then the two dyes would be at the same spot, and I mean, blue and yellow would again turn out to be green. So they're not going to get separated. So they have to have different solubilities. One should be more soluble, the other should be less soluble. Then there's another thing, and you can do this for amino acids. You can do this for other biological substances as well. Uh, Now, one extra thing that needs to be known is that a lot of biological substances like amino acids, they're not visible. Okay, for example, colored dyes, they're kind of very visible, but other biological substances are not very visible, especially amino acids. You can't really see them; they're colorless. So So biological substances like amino acids are not visible. And to make them visible, what you do is you spray them with a locating agent. Locating agents are compounds that change color when you put them on an amino acid or something. So you start seeing colored marks on them. ठीक है, so for example, the two amino acids, you can't see them, and as soon as you spray a locating agent on them, you start seeing them. They turn brown or red or orange, some color appears. So locating agents are used. One of the locating agents that's often used for amino acids is ninhydrin. So for amino acids, there's a substance called ninhydrin which is used, And if you spray it on the chromatogram, although the spots would be there, but you wouldn't be able to see them. But as soon as you spray an anhydrine on the chromatogram, you'd be able to see those two spots. अच्छा उसके अलावा ये there's another thing in chromatography, and that's known as an RF value. ठीक है, that's known as the retention factor, or the RF value. Now the RF value is very unique for each dye. No matter where you put, I mean, if this is an orange dye that you use frequently in different uh, inks that you make, this orange dye is going to have a very specific RF value. And that RF value is calculated by doing two things. One is you measure the distance that the orange dye is going to travel. Here, that's one thing. You measure the distance from the starting point. All distances are measured from the starting point, and you measure the distance that the solvent is going to travel. And that distance is also calculated from the starting point. So all your distances are measured from this line that you drew earlier, ठीक है, the pencil line, which is why it has to be in pencil, because you don't want it to be, uh, uh, I mean, you want it to be visible clearly. So this is the distance traveled by the dye, and by the orange dye, this one, and this is the distance that is traveled by the solvent. Let's give them some hypothetical values. For example, I'm going to say that this is 4 centimeters. ठीक है, just a hypothetical value, and this distance over here is 5 centimeters. In your exam, you would have to measure this value using a ruler. ठीक है, you just put a scale next to it and you measure the distance. Uh, so the retention factor has a specific formula, and that formula is that it is the distance that is traveled, or we can just say the distance of the dye divided by the distance that is traveled by the solvent. And it's always a unique value. Every component in the mixture is going to have a very unique RF value. So for example, for the orange dye, it's going to be so the orange dye is going to have a very specific retention factor, and that is going to be that it's going to be distance traveled by the dye, which is 4 centimeters, divided by the distance that is traveled by the solvent, which is 5 centimeters. So very specific. So a very specific value, 4 centimeters divided by 5 centimeters, and that gives you 0.8 centimeters. Okay, that's your RF value. And similarly, we can calculate the RF value for the other dye, which over here is the blue one. So it's going to be the distance traveled. So I'm going to rub this orange one, and we are going to do it for the blue one now. So it's the distance traveled by the blue dye divided by the distance traveled by the solvent. Now the distance traveled by the dye is, again, I'm just giving it a hypothetical value. It's my estimate, it must be around 2 centimeters. So it's going to be 2 centimeters divided by 5 centimeters. It's going to be the distance that the dye travels. So for the blue dye, it's going to be 2 centimeters divided by 5 centimeters. And the value that I'm going to get is what is 2 over 5? That's going to give me 0.4. Okay, and this is not in centimeters. Just, I mean, RF value has no units. Make sure don't write any units next to RF value. The RF value has no units. So one is 0.8 and the other one is 0.4. And this is always for the orange dye. This is always going to come out to be 0.8. I mean, specifically the one that we're using over here, TK, the hypothetical one, the one that you see over here. No matter what the chromatography is, if you're using the same dye, the RF value would always come out to be zero point 0.8. If you're using the same orange dye in some other chromatography, if somebody else is doing an experiment, if some other mixture contains this orange dye, the RF value would always remain zero point 0.8 for the same dye. If it's another different orange dye, then it would have a different RF value. But RF values are very unique to every, and they don't change. Okay, they're always fixed. Plus, about RF values, they're always less than one. Okay, they're always between, so they're always between 0 and 1. And if they're close to 0, that means they're not soluble in the solvent. I mean, the reason they're close to 0 is like the blue dye had a smaller RF value, and the reason it had a smaller RF value was that it wasn't traveling with the solvent as the chromatogram was absorbing water and the water was traveling upwards. The blue dye was not very soluble in the solvent and it was not traveling with it. So that means the blue dye was not very soluble. So if the RF value is small, that means the distance that the dye is going to travel, it's going to be smaller. And if the RF value is large, that means the distance that the dye is going to travel, it's going to be much, much larger. And it's going to be more soluble. So RF values are always between 0 and 1. And if it's close to 0, then that indicates dye is not soluble, and it covers a smaller or travels a smaller distance. And if it's close to 1, that would indicate that the dye is very soluble in the solvent that you're using. Okay, so that is what RF value is. Now, Isa, is this clear to everyone?
Yes.
Acha. Acha, now just do a small experiment. TK, send me a picture. What you can do is take a pencil. TK, let's say this is a pencil. Wrap a piece of tissue paper next to it. TK, take a small piece of. I'm just going to draw this over here. Attach it. Attach that piece of tissue paper. Put it in a glass of water. I mean, put it in a glass of water later. TK, first thing is you make all the lines, relevant lines. So here's a glass of water. TK, and the water has uh, and there's supposed to be some water in it. TK, you can do this experiment at your home. Take any ink. TK, take any ink, any marker that you have at your home. Draw a pencil line. No need to actually draw the pencil line. You can just directly put a mark over here and then dip it in the solvent and keep it there for some time. The water would be absorbed by the tissue paper, and the ink would start spreading, and it would spread into different components if it has different components in it. If it's a mixture of different dyes, some dyes would be more soluble, so they would travel a longer distance. Some would be less soluble, so they would be traveling a smaller distance. Okay, so try and send me a picture of what you obtain once you do this. Okay, everyone. And even try to, although the experiment would not be that good, but it would be, ठीक है, even try to calculate the RF values if you're able to spot different dyes. ठीक है, so send me a picture of this. ये try करना और बाकी रिवाइज कर लेना. ठीक है, we're almost done with the separation techniques. We'll do past paper questions now. चलिए ठीक है, okay then. See you tomorrow then. कोई question तो नहीं है किसी का? आमना ठीक है, I'll post this, ठीक है। चलिए, ओके, अल्लाह हाफिज।